Assalamu alaikum everyone. So today, let me start from the start. Okay, let me start from the start. So Assalamu alaikum everyone. This is Naeem, and today I'm thrilled to present to you Epidemius, a lightweight, deployable, generative AI medical assistant designed to bridge the gap in healthcare accessibility. In regions where technology resources are limited, traditional AI solutions fall short. Epidemius is my effort to bring AI powered medical guidance to the people who need it the most. Let me see the contents. The presentation is divided into three main sections: the problem statement and its solution, the functionality and the features of this app, and yes, the future goals. And yes, this whole video will also give you the demo of this app. Now let's see the problem statement. So millions of people worldwide lack access to the real-time medical guidance. This could be due to remote geography, financial constraints, or lack of medical facilities. So we have the Epidemius, a lightweight and deployable generative AI medical assistant aimed at enhancing healthcare accessibility. Existing AI healthcare solutions often require heavy GPU infrastructures. These solutions are costly to deploy, making them impractical for educational institutions or NGOs working in underdeveloped regions. Students and healthcare workers in the field need lightweight, offline, compatible, and ethical AI tools. They require guidance in the form of educational resources, not direct medical prescriptions. So, this scenario made it clear that we needed an assistant that is not only accurate and responsive but also deployable on everyday hardware, a tool that can run on a simple laptop or desktop without GPU acceleration. So, our solution is very simple. Before going to the technology overview, our solution is very simple, that we have to build a retrieval augmented generation RAG assistant rather than relying on massive cloud models. It leverages symptom-based diagnosis flow. It embeds a medical knowledge base directly within the application using vector database, eliminating any need for external files or API calls during runtime. So this is the technology overview in front of you, and before reading all these stuff, as this presentation is already attached with my form, you can read this presentation. Let me go with the tech stack. Everything is optimized for CPU deployment, making it perfect for low resource environments. So if we go with the tech stack, let's dive into the technology stack that powers Epidemius. So the UI layer is, we have used Gradio, a lightweight Python UI framework to design an initiative interface where users can input their symptoms. Next, we have the retrieval layer. We employ LangChain integrated with Chroma DB for managing the retrieval logic. This layer is responsible for fetching relevant medical data. Next, we have embeddings. The symptoms, descriptions, and medical knowledge base are embedded using HuggingFace sentence transformers, which convert textual data into searchable vectors. Next, we have large language models, which is LLaMA. For natural language responses, we utilize Mixtral or LLaMA models. Interfaced via Groq's API, which provides ultra-fast interference without even GPUs. Next, we have the deployment, and finally, everything is packed and deployed on Hugging Face space using GPU configurations, making it ideal for low-resource environments. This architecture ensures that Epidemius can function entirely on CPUs while maintaining the efficiency. So this is the high-level diagram. We combine the LangChain's logic flow with Groq's blazing fast LLMS, all wrapped inside an initiative Gradio UI. So before going to the functionality and features, we can go with the functionality and the features, like we have symptom-based diagnosis flow, we have RAG system, we have error handling and user experience as well. And as we connect this functionalities with the high-level system diagram, I can say that uh, uh, the user input symptoms into the Gradio interface. These symptoms are passed to a LangChain retrieval augmented generation, which is RAG. LangChain queries the vector database where all the medical knowledge is embedded. A prompt template then structures this retrieved information to be processed by the Groq API, which interfaces with the LLM. Finally, the LLM generates a human readable response that is displayed back on the Gradio UI. So these are the functions, core functionalities, which are already mentioned in the presentation. And before going to the future goals, let me give you the demo, because I know I have to do this. So this is my interface, which is very simple and quite understandable. You simply need to ask a medical question. Let me just write the symptoms, that I have flu and cough and fever, which is this app is not for the high level diseases. This is very basic one. So I just enter the daily problems we have, more usually in urban areas, the polluted one. So we have flu, cough, and fever, and the app is running. So we have common cold systems include sneezing, sore throat, and mild fever. Paracetamol is commonly used to reduce fever and relieve pain. Here you can see the lookup error, which is I am not going to hide it, because we worked on this lookup error, but we know that we are limited to the open AI sources. So now we have to back on the future goals, which we are actually working on it. So future goals are simple, that Epidemius is just a start. We are building towards a scalable ethical AI in healthcare education. We know that GPU ready upgrade. We need this sort of upgrading, and if we can say that we have the NLTK lookup error, we are operating in a CPU deployed Hugging Face space. Some Python libraries like NLTK PUNKT punct tokenizer are not bundled by default. This can cause a lookup error during runtime. So I'm not going to say that this is my lackness. Actually, this is not my lackness. We can fix it. We have the solutions. We can fix this. Our team is working on it. But in a limited time, we actually need a solution for our problem, and that solution is the Epidemius, uh, the generative AI medical assistant for the epidemiology, for contagious diseases, for those diseases which are contagious and need AI assistant promptly. So that's all from our side. I'm the team leader who is the presenter, and my other team members are mentioned. They worked on the content, they gave me the creative idea, and they also told me about the front end and the back end. Before running it directly onto the Hugging Face, we worked on Google Colab Notebook, and also we worked on Spider Notebook, so we can get the good of good code, and then we deployed on the Hugging Face. And still we have to do so many changes, because we need it more smooth and